So, ladies and gentlemen, we are now going into the next session, which is about technical application and process heat utilization and gas treatment. The first speaker in the session will be Mr. Dirk Bonse, I've known for several times. A sales manager of AT Syngas Technology N.V. He's an N.V. Namloze Vennootschap. This is a Dutch unit. Mr. Dirk, the time is yours.
Thank you very much. Yeah, to answer that question, so we are indeed a Dutch registered company. This is basically because it was easier to set up a European stock exchange company, but we are fully operational, 100% operating from Cologne, quite near to the Dutch border. Yeah, so I will speak today about Syngas Generation products, heat that can be generated from syngas, heat and power generation dedicatedly from biomass. So trying to switch the slide. Maybe somebody can help me, apparently. Thank you very much. So who we are and what we do are mainly providing syngas generation, power plants, and also dedicated heat plants. We offer raw and clean gas solutions for industrial applications in the range of 600 kW thermal up to 50 megawatt thermal. Also, we offer clean gas for decentralized power plants in the range of 200 kilowatt electrical up to 12 megawatt roundabout electrical. These decentralized power plants can be, of course, connected to the grid. Our plants are capable of delivering baseload capacity, but of course, it's also a topic for own energy consumption in industries. Our services cover feasibility, engineering, delivery, erection supervision, and of course, the after-sales support, spare parts, and maintenance. Next slide, please. Thank you. A short glimpse on our history. We actually stem from Klöckner-Humboldt-Deutz, which invented the so-called twin fire gasification principle. And the father of our CEO, of our owner, took the technology after A.H.T was dissolved. And we basically spinned ourselves off them from the original A.H.T and yeah, translated the technology to the demands of the current century. Next slide, please. Thank you. This is what a typical setup could look like. So the centerpiece is the so-called twin fire gasifier. What that means, I will explain a little bit later. We apply a gas cleaning system. In this case, we apply a wet gas cleaning system, as we can purify the gas to the best possible extent that you can either use syngas constituents or that you can use it with turbocharged high-efficient gensets or CHPs. The water is circulated, so we clean it up and put it actually back to the production cycle. Next slide, please. So this is what actually twin fire means. So in fixed bed gasification, there are actually two types of gasifiers, the so-called updraft gasifiers, where the gas is flowing against the biomass flow, and the syngas is stripped off in the upper part of the gasifier. So basically, you have a quite high tar content because it goes through the ungasified part of the gasifier, but at least a low ash content. The downdraft gasifier does it the other way around. And this way, you have a low tar content, but a high ash content as the syngas is stripped off near the ash zone. And so what we do is we combine both. So we have an updraft and a downdraft, a core and counter current flow. And the syngas is stripped off in the lower middle part of the gasifier. And this way, we have a low tar content and a low ash content. And also, the material is completely gasified, so that we only entrain pure ash. So this is also, of course, important because we also address waste reduction. Next slide, please. So here you can see what types of feedstock we like. Basically, we need a core structure. So in the easiest case, these would be wood chips, but we can also use harvest materials in briquetted form. So this is, for example, of interest for the palm oil industries. And we can also use sewage sludge. Thank you. it was a good point. By applying hydrothermal carbonization. So this turns any high liquid biomass, also sewage sludge, or manure or digestates from biogas plants into a hydrochar. This hydrochar can be gasified, but it also can be used as a soil improver. A relatively new project of us is the hydrogen separation from syngas. It is an advantage that we have already hydrogen in the syngas, up to 15, up to 30%, depending on the technology. And so we only need to separate it. So this means we need considerably low energy, and we can actually generate the hydrogen where it is needed. Next slide, please. So this is what a typical process chain or process change could look like. So we have a feedstock. Here the example of a high liquid feedstocks. We carbonize it, and then the hydrochar is formed. Either it goes then to the gas generation treatment, or it is used as a soil improver. The water phase we can also utilize. We can clean it up. We can distillate it to extract further fertilizers. And the good thing is we need very low energy to actually separate the water. So we do not need to pre-dry it. We simply later, in the carbonization process, we will press it out, because the hydrochar itself, it has actually water, it's coated a bit, so it does not recombine with the water. Then, of course, we have the opportunities to, thank you, to separate the hydrogen. We can separate CO, we can separate carbon dioxide. These are of interest for chemical industries. And of course, we can generate electricity and heat, and from that heat, of course, cold. Next slide, please. So to whom do we offer? So the center is, smart cities. We already heard today that there is an issue with volatile energy carriers like wind and solar. So our plants are perfect completion, because we deliver baseload energy, and our plants can also go down with the output or go up again, depending on how the other energy carriers, let's say, behave. As I said, we target chemical industries in need of a clean syngas. Please, one slide back. Thank you. Wood processing industries, farmers, cooperatives, production and manufacturing who need high process temperatures, process heat. Food and beverage, these industries, of course, bring their own waste, so they can practically have no expenditures anymore for heat. And of course, also important in Indonesia, independent power producers. And of course, sewage sludge plants, who also want to have CO2 neutral and energy neutral energy balance. Next slide, please. We are already in the market. We had 2 projects. One of these projects was in Tayan, Kalimantan. So it was a coal-fired power plant. Sorry, one slide back. Thank you. It was a coal-fired power plant at that time, and the output was a 6 megawatt electrical. Next slide. This is an example of an industrial application. It was also fired with low rank coal here. Output was 40 megawatt thermal, and it was used to produce iron ore pellets. Next slide, please. This is one of our latest projects and references. It's located in Switzerland, and it combines the hydrothermal carbonization with clean gas heat and power generation. We are in the midst to commission this plant. Unfortunately, due to the pandemic, we could not travel, but now the works are resumed. Next slide, please. This is an example we installed last year. It was a pilot plant, 150 kW, and it was also a hydrochar plant. The owner of this plant, he produced by an own developed technology, a kind of hydrochar. Next slide, please. This is an example of a grid-connected installation in Japan. It runs flawlessly since 2015, and 800 kW electrical are produced and given to the grid, serving 2,000 households. If you look in the picture on the left-hand side, you can see a hotel above the plant. So you can see it's in direct vicinity, which shows how clean such a plant actually works. So there is no noise, there is no odor, and otherwise the hotel obviously would not exist anymore. Next slide, please. These are my contact data. Of course, you will get the presentation afterwards. So you are also invited to click the YouTube link where you can see an explainer video about what we're doing. Thanks very much.
Dankjewel, Dirk. Ik zie dat je een Nederlander bent.
Yes, we do not speak Dutch, unfortunately, because we just are registered.
Yeah, of course. Of course not.
No, of course, the connections between the Netherlands and Indonesia, yes.
Okay. Thank you again, Dirk. And I do not give a comment on that. This is a very interesting presentation in itself. So, and I see that you have some clients in Indonesia, including in my birthplace, Surakarta.
Very good. Yeah, we are of course looking to extend this client base, and we are also looking, of course, for distributors and partners. Thanks very much.
Are you doing the waste to energy project?
Sorry, again, the waste to energy project?
Yes, are you doing waste to energy project? Your technology?
When you're talking about bio-waste, yes.
Okay. Thank you again. It's very interesting. So the second presenter is Mr. Matthias Gunther. He's a technical sales engineer of CAW Wiesloch GmbH. And he's going to talk industrial combustion and high temperature process heating systems. Mr. Gunther, please. The time is yours. So you have to unmute yourself. Stefan? There's a problem here. We can't hear you, Mr. Gunther.
You're actually on, Mr. Gunther.
Right
the
now.
Microphone is on.
Yes.
No, I cannot hear you.
No, please unmute yourself. Your microphone.
He is unmuted. He is unmuted. Switch on and off your microphone once. Maybe that works. Good. Off and on. Can you do that? Okay. Can you check under audio whether the audio is working?
Your audio setting perhaps have to be activated.
Yeah. So in the menu you see audio. You can maybe just check maybe the audio is on no audio. Okay. Okay. Yeah, maybe try switching off the camera. Maybe that helps. Try switching off and on the microphone once. Maybe that helps already. Because if I do it, it seems not working. Let's see now.
Can we switch to other, and then we can have Mr. Gunther back.
Can you hear me?
Yeah, now.
No? Yes, very good.
Yes,
now we can hear you.
I have restarted the system, and now it seems to work. Sorry for that problem, but at the beginning it was working. So now again, good afternoon to everybody, and good morning to good morning to Germany. My name is Matthias Gunther. I'm working for CAW Wiesloch company, short CAW, and we are a manufacturer and supplier of high temperature industrial heating systems. We are located in the south of Germany. So my slide moving is also not working. Maybe someone can move my slides.
Stefan?
So we are located in the south of Germany, also in Wiesloch. Yes, it's around 180 kilometers, or 80 to 100 kilometers south of Germany. So next, please. So our key activities are manufacturing and supply of high temperature process heating systems. Typically for process heating at high temperatures, if we are talking about high temperature, we are talking about temperatures above, let's say, 150 to 300 degrees. Also above 300 degrees, process heating is possible with special fluids and also with molten salt possibilities. The benefit of such a thermal heating system is that we can operate the system at high temperatures up to 300 degrees without any pressure inside the system. For example, if we have a system temperature of 250 degrees, we would have in steam systems around 40 bars, and the thermal heating system is still working without pressure. So next slide, please. This is a principal drawing of such a indirect heating system. We have at the left side the thermal heater, which is fired by means of a burner, or it can also be used with a biomass firing system. We have a pump below, which pumping through the circuit. We have the expansion system and the heat consuming system. Next slide, please. As fuel, we typically use for the simple systems fossil fuels like natural gas, light fuel, oil, or also heavy fuel oil. Typically, if we talk about efficiency, we combine this with so-called economizers, which uses the energy of the flue gases to give it back to the combustion air and to achieve highest efficiencies up to 96% efficiency. We also heat up our systems with biomass, with great firing systems, and also with production waste like liquid fuels, gaseous fuels is possible. Depends on the process, which is coming from the process, and also electrical heating is possible. Next slide, please. Here, the left side is such a direct fired thermal heater with a burner on the top, and we can see in the middle of this heater such a tube coil, which forms the combustion chamber. At the right side, we have such a heater combined with an economizer. Next slide, please. This is a heat exchanger showing. This was a heat exchanger, which is installed in our biomass firing systems to extrude the heat from the flue gases. here you can see biomass firing system in a sawmill in Canada, from the pre-planning and then after erection. Next slide, please. This is this heat exchanger, which is installed in such biomass heating systems. The benefit of such a blank tube heat exchanger is that it can be cleaned very easily, for example, by a shot cleaning system. Next slide, please. During manufacturing of a pipe coil, which is installed in these direct fired heaters. Next slide, please. And after manufacturing of a thermal heater and made ready for transportation. Next slide, please. This is a small direct fired thermal heater in combination with the indirect steam generation. The benefit is that we have such an indirect steam generator, which is not fired. It's handled from official side only as a pressure vessel. So there is no need by law to operate this as a steam generator because it's only a pressure vessel. Next slide, please.
1 minute to go, Mr. Günther.
Yep. Here's some references, and we can see here the left side heater with highest efficiency and with lowest NOx emissions. Next slide, please. Example of installations with air preheating. The left side is installed in China for a PET plant, and the right picture is power plant, solar power plant in Spain. It's operated for 400 degrees. And here we have some references in refineries where we use refinery gas and residues from the refinery to generate heat. Next slide, please. Some biomass installations in combination with power generation, with RC power generation. Next slide, please. Thank you very much for your attention, and I wish you an interesting conference. Thank you.
Thank you very much, Mr. Günther. And we are sorry about this, the problem in the beginning of your speech. So it's fortunately it has been solved, and it was an excellent presentation. Give you an overall picture of what you are producing. Okay.
Thank you.
Theo. Now the third speaker is someone I know. Yeah, this is a young man. He's been very active in energy efficiency movement. So he's my friend Niels Wobber. He is Chief Representative of Southeast Asia APROVIS Energy Systems GmbH. And he wants to present increased energy efficiency through gas treatment and heat recovery. Niels, the time is yours.
Thank you very much, John, for the nice welcoming words. So I don't have to introduce myself anymore. Anyway, warm welcome. Warm welcome to the audience and everybody who is still with us. Yeah, we have 2 hours already behind us. I see roughly 100 participants from external audience still in the line. Thank you for still joining. It will pay off. So the next 10 minutes, we will focus indeed on the combined heat and power, so CHP. We have heard that before in several slides already. And as I'm the representative of APROVIS Energy Systems in Southeast Asia, I'm representing this German-based company, medium-sized company here in the region. I just see that I also need to ask your assistance to skip the slides one further, please. From my side, it's not working. Thank you. So just to give you the brief impression, in the south of Germany, roughly 2 hours from Munich, we are located with a headquarter, a medium-sized company, and we are equipment supplier for equipment all around the gas engine or small-scale gas turbine. So I'm calling from Indonesia, actually, 1 hour flight from Jakarta, from Yogyakarta, where we have our representative office for the region Southeast Asia, which I'm leading here since roughly 1 year. So now with this flowchart, mainly you can see the products that we have in 2 product division, but also what is necessary to operate a CHP plant, the genset plant, the energy production using a gas engine or a small-scale gas turbine properly. So we see on the one hand the fuel gas treatment, if we call it the green product line, so meaning if we run on any kind of biogas, landfill gas, sewage gas, or synthetic gas, yeah, what we have heard before. So this gas need to be treated in a certain way before entering the gas engine or gas turbine. This gas treatment, you see the APROVIS logo on top of this equipment. This is what we provide in collaboration with the gas engine manufacturer. So the red rectangular showing the core of the plant, this is not APROVIS equipment. This is provided by several companies, manufacturers, well-known companies. And then we focus with the CHP components on the exhaust gas line. So here we see the exhaust gas line coming out of this energy production facility, and the components for emission control we have in our scope of supply, as well as the heat recovery. Heat recovery to raise the energy efficiency of this overall plant. So we will focus with the next slide and the next slides on this part here, the energy efficiency setup with CHP. Before that, I would simply show you the conventional setup so that we are all in the same picture. We have a factory. Yeah, we take the example of a factory, which is producing a certain product. It can be also, yeah, we take the example of a factory. To produce this product, we need some kind of electricity to run the pumps, the conveyor belts. We need cooling power to cool the factory to cool product, or we need thermal power, as we heard before, to have a thermal boiler or thermal circuit like hot water, thermal oil, or steam. For that, in a conventional setup, we have the electricity coming from PLN, from electricity line, and the gas supply, for example, it can be also coal, any kind of fuel, to actually run the heat source, the steam boiler or the thermal oil boiler. So now compared with the CHP setup on the next slide, we see here we have a combination. Still, we have the same factory with the same output of a certain product, which is the focus of everything. But now we see here we have a combination using a gas engine or gas turbine, a combination of electricity production, which you see here in the yellow arrow on top. And then at the same time, out of the heat recovery, we can produce either way cooling power. We can produce steam on a certain steam pressure level. We can also produce heat or actually support the existing heating circuit with thermal oil, hot water. It can be also actually in the end incremental power. If we talk about the pure electricity production, even with the exhaust gas heat or the waste heat, it can be utilized to increase the overall electric production. So all these options we have on the table. We are equipment supplier again, yeah. So I'm showing you simply what is possible, not that we have all this in our scope of supply, but we can assist you to evaluate what is suitable for your approach, for your project, or for your plant, and then somehow guide you through the beginning of this evaluation, and in the end, serve with our equipment, which has proven worldwide in several cases. Next slide, please. Again, now the CHP example in reality, simple one. So to give you also here, to round up the picture, we see now the example of the gas engine, a certain gas engine, a certain size, let's say 1 megawatt, 2 megawatt. Yeah, this gas engine is usually running on natural gas and producing electric power to supply this electric power to the factory. We have hot exhaust gas coming out of this gas engine, and it could be dumped directly to the environment, but we are here to learn about energy efficiency, and state-of-the-art proven technology in Europe, in America, and Australia is actually to utilize this exhaust gas heat in simple equipment like a heat exchanger, exhaust gas heat exchanger, no additional firing necessary. But from this exhaust gas, in combination maybe also with jacket water coming from the gas engine, yeah, there are several heat sources actually, waste heat sources, to take this waste heat and produce additionally from the same original fuel source, we produce additionally hot water. If we talk, for example, about the globe production, which is has raised by 600% now due to the COVID situation worldwide. The globe production, they need hot water on a certain level, 140 degrees. We can provide that with this kind of equipment and at least support the existing system. Why we are doing this? Because then the energy bill will be lowered. We can substitute a certain amount of hot water with this system. So it's a combination of heat and electric power. It can be also cooling power, whatever is needed. Here I want to also to quote again Ms. Jana Köberlein from Fraunhofer Institute. She mentioned correctly, higher energy efficiency is bought with less energy flexibility. And this is why you can see this picture, why this equipment is fully depending on this gas engine operation. So once the gas engine is running, also here we have a certain heat production, which can also be bypassed. So we can switch this one off, but we cannot produce heat without electricity. This is what is behind this flexibility, which we give up a certain portion to buy efficiency. Next one, please. The motivation behind this, why energy efficiency is shown in this table, where we see the standard energy efficiency, the general efficiency ratio actually for certain types of power plants. We have like the typical thermal power plant up to 40% electric efficiency, meaning 60% of the initial fuel going to that plant is dumped to the environment. The gas engine generators come already with 40 to 50%. And now we talk about the energy efficiency measures, which we take additionally, like the combined cycle or C cycle, to raise a certain percentage. Or if we want to reach the really green zone, the higher level of 60, 70, 80%, we need to talk about combined heat and power, CHP. This is what is behind this table, to have a broad picture where we are ending with the efficiency to get simply more out of the fuel that you have to pay on a yearly or daily basis. Next one, please. So to simply summarize the product range here, as I mentioned, gas processing, gas heat exchangers is what we have for the green production, for the biogas production. We have the emission control equipment and steam generators, but purely the heat recovery solution. It's not the direct fired one. Same for the exhaust gas heat exchangers. And what I would like to convey is a message here: whenever you have a gas engine or gas turbine project as an IPP, an EPC, or the engine distributors, these are our partners to work together to sort out the most efficient setup and the best setup in terms also of capex for this project. So we help with ROI calculation. We help to actually get a nice broad picture of this project and then connect with certain partners to move on. Next one, please. With that, we work together since years with all the big names for the engine, from engine manufacturers. You see Rolls-Royce, Wärtsilä, Jenbacher for sure, MTU, MWM, Caterpillar, all these brands. We have a close relationship and supply directly to these engine manufacturers as an OEM supplier. But with our office here, we offer here in Indonesia and for Southeast Asia. Yeah, next slide, please. Yeah, we offer to develop the project together in the same time zone, so we are close with you. And here in Indonesia especially, I want to mention we work together since 3 years closely with our partner KEI, with Mr. Irfan. You see the contact data here. He's representing us in Jakarta, with an office in Jakarta for our partner. We have the office in Yogyakarta with myself and a small team sitting here. Also, after sales is managed from here. So we are close, and please contact us for any inquiry And with that word, I would like to hand over to the last presentation. Thank you very much.
Thank you, Niels. It's an overall picture of your capability of product lines, and hopefully it is going to grow faster in Indonesia. The last speaker at this session is going to talk about thermal oil plants for heat recovery efficiency, and then Mr. Christian Daniel is ready from INTEC Engineering GmbH. Mr. Daniel, the time is yours.
Thank you very much. Okay, I'm not sure why we can't see the webcam, but I guess now it's also on. Yes, good afternoon to you in Indonesia from my side. My name is Christian Daniel. I'm representing the company INTEC. I am very pleased to have again the opportunity to work with Econit for another presentation over the years. Who is INTEC? INTEC is the main and the largest German company supplying high temperature process heat for the industry, as well as different renewable power generation solutions. Next slide, please. Okay, so our company has been set up 25 years ago. We are based in southern part of Germany. We are doing a turnaround of 25 to 35 million euro per year, also depending on very large projects in the power generation business. This can exceed this figure. And we have, of course, developed a very intensive contact to our customers, also setting up local offices. As an example, we have a local representation office in Malaysia, which is caring for Southeast Asia, but also different representations worldwide. Our business is to provide complete solutions from heat to power. So it's a quite big range, many different products, and beyond this, from heat to power solutions, which we will see later in more details. Also, we are offering the handling opportunity for sludge drying. This is getting more important in Europe, the opportunity to dry and to incinerate the sewage sludge from water treatment. INTEC has been working worldwide since long time, so we have many installations around the world. Of course, several installations with thermal energy supply, and we have been participating in many power projects, power generation projects across the world, mainly in Southeast Asia. What we are doing is that we are doing the complete design and engineering for such plants, very often together, a joint development with the customer to see what is exactly the needs of the customer. We are happy to do the complete engineering around this. The manufacturing of the key components are done at our production facility in Germany. But also for many different projects, we can offer to the customers local supply, as done with many other customers in Indonesia. But also a turnkey installation is also in our reach. Of course, all these deliveries are accompanied by the supervisors for the installation and the service engineers to do the commissioning and the after sales and support after the startup of the plant. The range of products, of course, we have seen there are thermal oil heaters, many different orientations. The picture is showing our so-called three-stage rocket design with a very small footprint, which is incorporating the thermal oil heater, the economizer, the stack, everything with a high efficiency up to 95% and the capacities of 30 megawatt. As an example, one of the largest heaters in this way is installed in Gresik near Surabaya for a customer from the oleochemical business. The capacity there is 24 megawatt in one single unit. Also interesting products are the waste heat recovery boilers. We have different technical executions for this. It can be a one-pass radiation heater multi-pass radiation heaters, convection sections with tube bundles that's shown in the picture, 3-pass heaters, many different applications. And the media which we are working with is thermal oil, temperatures up to 400 degrees, steam, hot water, or very often also hot gases after their own combustion system. Important for the oleochemical business, which is palm oil business, which is also very strong in Indonesia. Also the high pressure steam boilers. Here we have large customers in this business like Sinarmas, Musimas, and Wilmar. The high pressure steam boilers, especially the closed circuit steam boilers, we are offering with a pressure up to 100 bar and capacity up to 10 tons. The standard ones for the open systems are exceeding this capacity and achieve much higher capacities up to 300 tons or more with 135 bar. All these units can be fired by natural gas or fuel oil, or of course in combination with a biomass combustion system, which we are offering also. Steam generators are heated by thermal oil. Also here we have installations in Indonesia, in Sumatra, near Medan. So capacity there is up to 40 tons per hour and the pressure is going up to 60 bar with very easy regulation and no attached firing system. We have seen the equipment which is fired by natural gas and fuel oil. Of course, we have also the own combustion systems for biomass. This can be a reciprocating step grade designed especially for biomass. This is very important. So we have been offering our energy plants since 20 years in Southeast Asia. Capacity up to 100 megawatt. And we are working with many different fuels, can be a very poor quality, up to 100% moisture, 180% moisture, and many different biomasses. Also, now the latest project is using the palm oil trunks to use every waste from the production opportunities. In parallel to this, we have the fluidized bed combustion. So we are very happy to offer both systems from one hand. In this case, we can choose what is the most suitable technology for our customers. The fluidized bed combustion system is often used also for coal firing, which we have thermal oil-fired coal heaters operating successfully in Southeast Asia, and also the sewage sludge incineration systems. And all this, of course, can be combined with the individual components which you have seen. We combine this in the complete energy plant. Here the energy plant is supplying simple heat for the manufacturing process. Very often this application is mainly for larger capacities, up to 100 megawatt, mainly for the wood industry. Also have customers in Indonesia, in Sumatra, in Palembang. And here in this kind of situation, you are burning the complete waste from the production. This can be bark, wood chips, fines, sanding dust, also other fuels are possible, like rice husk, empty fruit bunches, and other biomass. And the same issue here, using thermal oil, steam, or hot gas as heat transfer medium. Besides this, we have, of course, the power generation, the cogeneration plants. Most of the installations are running in Southeast Asia, in Thailand, capacity up to 20 megawatt electrical. And also here the fuels are very, very different, can be wood chips, bark. Very often we have rice husk from the rice mills, but also different biomasses. Also it goes towards RDF, municipal waste, more and more active now in Indonesia. We have many projects offering waste to energy plants to remove the municipal waste also from the landfill. And this is the opportunity to do either standard power plant with electrical power generation, or also a cogeneration plant to supply steam for the manufacturing process. A different branch in the power generation itself is the organic Rankine cycle. The organic Rankine cycle and the turbines for this have been done in-house, so we have our own components for this since more than 20 years developed. We are serving here three main areas, applications. One is the waste heat recovery from the industry, where you have a waste heat stream which is not used. You can recover the heat, transfer it to thermal oil, and with thermal oil you are heating up the organic Rankine cycle. Similarly, this is done with biomass, where you have a standard biomass-fired plant, and you generate with the ORC unit electrical power. The off-product from this ORC unit is, of course, a large amount of hot water, which is also used for different customers' application. And last but not least is the geothermal power plant, where you simply tap the hot water from the ground and turn it into electricity. Another area is the thermal sewage sludge utilization. In Europe, it is getting more and more important because we are not allowed anymore to take out the sludge to the fields because it's contaminating the soil, it's contaminating the groundwater, it contains a lot of biogenes, residues from medicine, also sometimes heavy metals and so on, and which all these units and components are not removed in the wastewater treatment. They are staying in the sludge, and this sludge must now be incinerated, of course first tried and then incinerated to make the sludge inert and to take the ash to the landfill. And for this also we have our own products to dry the sludge. We have high temperature sludge dryers using hot oil or steam, which are due to the high temperature. We overcome the problem in the drying, the sticky phase of the sludge. We overcome that very, very fast without any problems. And we can move easily into the drying of the sludge and preparation for the incineration. The units are
1 minute to go, Mr. Daniel.
Perfect, thank you. Yeah, so the units are very, very compact. I'm already prepared to be fast. So thank you very much for attending. So we will be very happy either directly with me or with our local team in Malaysia to receive your questions and inquiries. When receiving this presentation, we'll have in the back further slides with many references of our installations, where the time is not allowing now to go through that, but you will find it in this presentation. Thank you very much. And looking forward.
Thank you again, Mr. Daniel. Okay.
Yeah.
Okay, we come to end of this the second or the third session. Stefan, any question?
The questions are answered via the Q&A section of the software.
Okay.
I think we can continue with the finance part. Yeah.
Good, so thank you very much.